Waiting for the recording to start. Okay, it was started. Great, let's go. So, hello everyone. My name is Paris. Thanks a lot for joining me today for this presentation. As Thanasi said, I'm co-founder of SourceLair, the company that we together co-founded a few years ago, and also I'm one of the co-organizers of the Docker Athens Meetup. So, whatever has to do with Docker containers, infrastructure, and automation really excites me. This is actually my work and what I do. So let's cut to the chase. I'm going to share my screen and start the presentation right away without further ado. So I guess you should be able to see my screen right now. Thanasis, can you confirm this to me?
Yep.
Okay. So today we will be talking about the Docker Compose CLI for AWS and for ECS more particularly. So who am I? My name is Paris. I am founder of Logic, a new company that I founded so we can solve problems and provide solutions to small businesses and individual people. I am co-founder of SourceLair, a company that's targeted to software developers and companies that employ software developers. I run a podcast with my business partner, Antonis, which is called Mikri Kouventa. You can find the link here. And as I also said a few minutes ago, I'm co-organizer of the Docker Athens User Group, and you can find more about that at docker.gr. So let's get into the topic, the Docker Compose CLI, and make an introduction to it. So what is the Docker Compose CLI? The Docker Compose CLI is a new uniform command line interface, a tool that I can run in my computer's terminal to manage applications, and more particularly, cloud-native applications. But we'll get a bit more into that later. What I can do is I can describe my application stack in a very simple industry standards file, and then develop, build, and publish whole application stacks with a single tool. So this is a problem that Docker does usually. It creates tools and uses the same name slightly different, and it drives confusion. So in case you have seen and had an experience in the past with Docker Compose, this is a completely different tool, Docker space Compose, let's say, but it serves the same purpose. So let's see what are the main differences that we have to keep in mind in case we are familiar with both, with the previous tool. If you don't know Docker Compose, that's better for you to go straight tabula rasa into what we are showcasing today. But it's a useful thing to know the differences between these two worlds. First of all, the Docker Compose CLI is part of the Docker CLI. It's an extension to it. So you run the Docker command that you would usually run, followed by a space and then compose, just like you would do Docker space containers, Docker space images, and all that stuff. A funny story here is that in 2014, Thanas and I were in DockerCon in Amsterdam, and this is when they first presented Docker Compose, and they asked the people, okay, so how would you like us to handle this? Should we make it a completely different tool, or should we make it part of the Docker toolset? And the developers at that point wanted a completely different tool, which is what happened eventually. But right now, we're going back to the initial proposal of how this should have been, being part of the Docker made command line interface. So apart from that trivia, let's move on and say that the.
Sorry, Paris, can you stop the sharing and share again, because someone hijacked the sharing? Thanks.
Okay. Sharing again. Just give me a moment. Just a moment. All right. Going right back to it. Here is my screen. Can you see my screen?
Yes.
All right. So what we're talking today is the Docker Compose CLI, which is part of the general Docker command line tool. It is written in Go, in contrary with the legacy Docker-Compose, which is written in Python. This means much faster startup times, since it doesn't need to interpret the language at this point. And the other really important difference, which is what we will be dealing with today, is that it supports multiple backends, multiple type of contexts, as we can see later on, which means that I can run my workloads locally if I have a Docker engine running on AWS, ECS, on Azure, ACI, on Kubernetes, or whatever. While with the classic Docker Compose tool, I would just have a local backend, meaning just running stuff on my computer. So why do this presentation and use this tool called the Docker Compose CLI? So it provides straightforward cloud native application development. And what does that mean? The way we develop workloads changes. And right now we have Docker files as first-class citizens in our repositories. And we always have in mind that our applications are going to run on the cloud. And what Docker Compose CLI does, it helps us develop these applications like running on the cloud, but on our computer, using the same primitives, the same configuration, and all that stuff. Now, the next thing is that it uses an industry standard Compose specification. I will have a link to that later, but it's really important to say that the Compose file is now an industry standard. What does that mean? It has been accepted as a valid configuration language by Docker, of course, because they are the ones that created it, by Microsoft, by Amazon, which means that more and more vendors are building on the configuration specification of the Docker Compose CLI, which is actually, it does what Kubernetes configuration does, but it's really, really, really much simpler. As you can see later, we will be able to deploy a real application with just a few lines of YAML, crystal clear. And for the majority of the workloads that we run on the cloud, it's perfect. And the last thing is that we can use the same commands in local development and on cloud providers like AWS. This is super important because I am involved in a few projects that are backed by Kubernetes on production. Kubernetes is a container orchestration tool. It's quite popular, actually. It was started by Google a few years ago, but it's super flexible, super customizable, but it's not easy to run Kubernetes on your computer. I mean, okay, you can get it with Docker Desktop, but still it's kind of heavyweight lifting for your computer. But with Docker Compose CLI, you can have that simple industry standard configuration that is straightforward to translate to local Docker containers and, let's say, AWS workloads. Now, let's cut to the real chase. We will see, because we're going to get our hands dirty during this presentation. We are going to see how to develop a web application with the Docker Compose CLI. So what do we need? We need the latest Docker Desktop on macOS or Windows, or the latest Compose CLI on Linux. It has an installation script that you have to run to get it running on Linux, because the Compose CLI is an extension to the Docker client. And in order to get things working right, you have to do a few steps. But if you copy and just curl the installation script that has in its GitHub page, this is going to work. I have a link to this GitHub page at the end of the presentation, which we are going to share in the meetup afterwards. So you will be able to do this if you're running on Linux. It works. I have tried this. And then just your editor of choice. Now, what do we have to do? First, we need to create a Docker file for our app. The Docker file is, let's say, the recipe that knows how to construct the image of our application. And the image is the whole file system that we need to run our application, including the operating system. Then we're going to create a Docker Compose baseline, which is the baseline configuration of our application that is valid both on our local computer and on the cloud. And then we're going to create the docker-compose override.yml file that has sprinkles for development locally. And then we're going to write some code. Next, what are we going to build? So this is going to be a really simple application. We're going to use Python 3.8. We're going to use Flask as the web framework for our application. And we're going to return the host name of our process when we open that process in the browser, so as to know from what container we're getting the response. And we're going to publish this image on Docker Hub publicly. So let's get to it. Let's go back here and see the steps, and let's go and build this app. So here is my editor. I'm going to zoom in, and I have already created the Docker file here, just for the sake of convenience. So is this visible to everyone? Is it okay?
I think yes.
Yes.
Okay. So what we're doing is we're using Python 3.8 in our Docker file. Then we're installing Flask, which is the web application framework that we will be using. We are setting the working directory of our container. We're copying our files. And here we set some Flask configuration so as to know how to run our applications. So we will open up our application to see what it does. What it does is that it defines a simple route. So when I just open this application, it is going to respond with hello and the host name of the container. So let's see how this works. Let's go here to the terminal. I'm going to do Docker, build. I will name this AWS example. So this is building my application right now. Okay. Let me run this. And I will run Docker run. I'll get a terminal and an input. I will export port, let's say 5000 to 5000, run this, and I think it's Flask run, the command. That's fine. The port is already allocated, so I will use another port here. Okay. So as you can see, this runs my application after I build it. Let's go here to port. Okay, this should be working actually right now. Yeah, no, it shouldn't be working. That's right. // host 0000. Sorry about that. Now it's going to be working. So now, as you can see, this responds with the ID of the container because this is the host name it gets automatically. And if I do this another time in another terminal, of course, I have to change the port here because it's going to have a conflict. Here I get the different IDs or the ID of each different container that serves my application. You'll see why that matters later on. So let's stop this. So this is what our application does, but we haven't used Docker Compose yet. So let's see what do we need to do to use Docker Compose. This was just plain Docker. We need to create, let's go back to the presentation. Come on. So we need to create a Docker Compose YML baseline. Let's go and do that. Here, we're going to add that part of the configuration that is the same across development and a workload running on the cloud. So first of all, we have to define the version of our application, which is 3.8 always. And we're going to go to services. We're going to name this web. We're going to give a name to this image, which will be Paris/AWS User Group Mikri Compose CLI. We're going to say to Docker Compose how to build our image. And then we're going to say that we want to expose some ports, and we're going to use port 80 here. And you'll see later why, but it's also the most convenient. And then we're going to say what command to run for our container. And the command will be flask run host 0000 and port, we're going to use 80. This is not mandatory right now to use port 80, but this will be imposed later on by AWS. So let's be a bit proactive on this. So what do we do right now? Instead of doing Docker build and then Docker run, we're going to use a simple command named Docker Compose app build. So what this is going to do, it is going to read the Docker Compose file that we have here and spawn the containers based on the configuration we have. It will automatically expose the ports here. It's going to automatically add this command and do everything right. It's going to build an image based on the current working directory and give it this tag. So let's go here. I will use another. Okay, so from what you can see, it just worked. If I just stop this does not work anymore. But what's the problem with this format right now? If I go here and let's say I want to change hello to hi, I still get hello here. And the problem is that I need to rebuild my container, which is certainly is not convenient. So I need a better way to be able to develop with Docker Compose locally. What are we going to do for that? We're going to create a new file named here docker-compose.override.yml. What I'm going to do here is I'm going to add only the additional documentation that I need to add to my file just for development, which is going to be always, we need to say what version we're using, and then services, web. And the only thing that I need differently for development is mounting the current working directory in the current working directory of the container, which is usr src app. So I will say volumes. Now, it would be really convenient if I would run Docker Compose app and just do this, but unfortunately, compared with the previous version of Docker-Compose, Docker space compose does not automatically detect the override file and merge this. So I have two options here. One option is adding the F here parameter, which I would just add the 2 files. This is going to work pretty nice. So as you can see, I have the new version here saying, oh, hi. And if I go back and change this to hello and put 3 exclamation marks, it will automatically change here. Why this happened is because I went to the override file and I said to it, okay, bind mount my current working directory into USR src app. And then I went to Docker Compose and instructed it to use both Compose files. I separated this in 2 files because I do not want to bind mount any directory when this is running on the cloud. This only makes sense for local development. So I need 2 different files. So we got our hands dirty. And before moving on to the next part, to Docker Compose CLI for ECS, I would like to make a brief pause and ask if everything is clear. If you want us to revisit any previous part, just let me know.
Anyone who wants to ask a question, please, you can use the raise hand feature, or you can add your questions to the Q&A on the top right corner. And if we have any questions, I will forward them to Paris. I think you can continue for now, Paris.
All right. Let's do this. So we did a quick run through for the development process of how we can develop our application with a new Compose CLI. But here tonight actually, we are to see how this works exceptionally well with ECS. So Docker Compose CLI for ECS lets us deploy to ECS Fargate containers serverless using the same Docker Compose configuration. It has built-in load balancing, built-in scaling and auto-scaling, secret management, service discovery. It's bananas completely. It's amazingly well built into the whole workflow. I love it. So how do we deploy on ECS via the Docker Compose CLI? We need an active AWS account, apparently, so we can have our workloads there. We need to configure the AWS credentials locally. And we need, again, the latest Docker desktop installed on macOS or on Windows, or the Compose CLI on Linux. Same thing with development. It's the exact same thing that we have, that we need to have installed. I will not run through any of these prerequisites. I think they are quite generic, and you can find the way how to do them in case you don't have already. But let's talk a bit about what happens under the hood. It's really important to understand that the Compose CLI does no black magic. There's no black box. It just transforms everything into AWS resources. More particularly, what it does, it deploys everything as a CloudFormation stack. There's no black box. And this is really, really important because I really love tools that work out of the box, but I hate it when I am constrained by the way they have architectured it, and I cannot do my thing in the output. And this concept was first introduced by Docker a few years ago, and they were saying that Docker should always be batteries included, but battery swappable. And this value still lives as a core part of Compose CLI. And you can see this because not only everything is a CloudFormation stack, but if you want to or have to, you can also access and modify the CloudFormation stack before deploying it. And I'm doing this actually in a few projects. So it's really important for me that it is there. So again, everything is CloudFormation and AWS resources. Nothing is black boxed. Compose CLI is just a sophisticated super smart client. Now, how do we do this? We're going to create an ECS context in Docker client. We'll talk about contexts in a few minutes. Then we're going to create, just like we create the override file, we're going to create a Docker Compose ECS file for the ECS sprinkles that we want on top of our configuration. And then we're going to just run Docker Compose app. And really, that's it. It's the same mechanism for running on AWS, just the same with running them on our computers. It's fascinating, really. I really hate using lots of tools and different configurations and different kind of stuff. I want to describe my stuff one and then just create. And with this tool, I can just do that. I'm really not being paid by Docker or AWS to say these things, but they have really transformed the way I work for the past year. This is why I'm so enthusiastic about this. Okay, so let's talk a bit about contexts. So Docker can connect to multiple hosts. Docker has a server client model. So I can have a context that connects to the local Docker engine. I have a context that connects to a remote Docker engine that I have, or a different Docker-like backend. For this specific purpose here, we need to create an ECS context in the Docker client. Let's go and see how that works. So we have, let me remove this. We have the Docker context subcommand. As you can see, I can create contexts here. Docker context create. As you can see, it requires only one argument, and here the name of the context, but I can do Docker context create ECS. Here, this is a special subcommand that when I give, let's see how this works. I can give a few here parameters on how to create a context that knows how to connect to ECS. So what I'm going to do here is I'm going to create that context from a local profile called SL. This is a local AWS profile. If you have configured it in your local AWS configuration, this will just work. And I'm going to name this AWS GR. So I have my context here. We're going to use this for our next commands. And let me move the presentation here, maybe. Now let's go and create the Docker-Compose ECS YML file. Actually, before doing this, let's just go and run Docker Compose app to see what happens here. We will do Docker -- context AWS GR Compose app. Let's see how this works. As you can see here, it says that, okay, I cannot use build because it's an unsupported attribute, but we don't care about this. This is going to just ignore it. And as you can see here, this starts the creation process on AWS, and it creates ECS clusters, log groups, networks, everything. And if I go to the AWS console here, let's just move. This is the right account? Yeah. Let's go to CloudFormation. Here you can see it creates my application. Let's give it a few minutes. It will take a bit. Here you can see all the events, everything that is being created is available here. You can see the resources. It's amazing. It creates load balancers, the target groups, everything. Just give it the load balancer is gonna take a couple of minutes. So it's a good opportunity if you'd like to ask any question.
I have a question. Is it possible to set up a context using roles? So if I run Docker Compose in an EC2 instance, I usually assign a role to that EC2 instance. So is it possible to set up context using a role, or do I always have to use credentials and profiles?
No. You have to use credentials. So what I can think of as the best use case close to that is creating an IAM user that has the exact rights that you want. If you go to the document, if you go into the documentation of the Docker for ECS tool, it has, I think it lists every single permission that it needs. Of course, I am an admin in my own account, so I don't have any problem right now.
I mean, also, even the profile addition is nice, because I think the first time I tried it, I had to put the access tokens.
Yeah, indeed. And also they have improved drastically the merging process of the different files since the last presentation. So it's good timing that we're doing this right now. We will see this in a little bit. So as you can see from now on, I really did not do anything additional on my code. I just it really just worked. It's magic. It's magic, really. Okay.
Could you also show us the template generated?
Yes. When this actually, I'm waiting for this to. No, I will go to another terminal actually, because I was
you
waiting.
could even show it in the UI of CloudFormation. It should be there in the template tab.
Okay, stack actions.
It's there in the template tab. If you.
Okay. So maybe I think we should open this in a designer, or is it better to see it here? Because I think it's not the most readable thing. Yeah, let me just.
Classic. It's classic CloudFormation bloated.
Yeah, but anyway, so here, if instead of Docker Compose app, we do Docker Compose convert, and then output this to a file. Okay, so with convert, we can convert our compose file to the primitives that we want to use. In this case, because of our context, this is in a CloudFormation configuration. So here we have a valid YAML with all these properties that we get out of the box. So also, if you think about that, from literally 10 lines of code, including the last new line, I'm being generous here, we get automatically more than 200 lines of AWS bloatware that I don't care about, really. And that's the whole magic here. And not only that, I can also configure stuff and reuse load balancers, reuse everything, or get this CloudFormation file and add my own stuff in the meantime. It's amazing. So let's go back here. So as you can see, we have everything created here. What I would like to do is first of all, I want to open up the cluster, see that everything works. I have a service here based on my own service, if you can see. It has a task definition, which says how my containers should run. It's amazing. All this stuff were created by Brave blocked this. Anyway, here it has created my container. This is the image that it's going to use. And before going back to it, let's go to the load balancers. EC2. Here, load balancers. Here is my load balancer. I will get the DNS name. Boom. And there you go. This is the host name of my container running on AWS. I did not change a single thing. So that's cool. but we have a few more cooler things to see. So let's go back to it. I really got excited about this. I could talk about years. So how do we scale on ECS via the Docker Compose CLI? So there are two types of scaling. First of all, we can scale the size of our containers, and then we can scale the number of our containers. So we do this with regular compose type of containers. Let's see how that works. We're going to go here in Docker Compose, and I will add. So no, right now we're going to break this down to different files because locally, most probably I don't want to scale this thing. Also, if I am binding ports, this is not going to work locally. So right now, it's a good chance to use a different file for the ECS sprinkles that I want to use. Now, I'm going to open up the wrong window. I think this is the, no, I forgot my editor. No, come on, come on. There we go. A new file, docker-compose.ecs.yml. So what we're doing here is we're saying version 3.8 services web. And now I want to say, let's go and see something here. Let's go to the ECS cluster. Let's go to the tasks and see how big they are. So if we go to the task definition, as you can see, we have 512 megabytes of memory and 1/4 of CPU time. This is, of course, it's enough for what we're doing, but let's say we would like to increase this. We will see this as a next step. First, we will try to just increase the number of containers that we run. So I'll say replicas 5. Now, what I'm going to do is I'm going to go here that I run this command, and I will just add after compose f docker compose yml and f docker compose ecs yml app.
So Paris, while we're waiting for the deployment to run, we have a question from Costas.
Yeah, of course.
He asked if it's possible to also define and modify other CloudFormation resources in the Docker Compose ECS YAML, or if it's just the resources of the containers in ECS.
So there are two things. First of all, you can define, I think, only for target groups and listener. This is about the web balance, the load balancer. You can define some updates in the Docker Compose file. So there you can, for example, you can instruct the listener to listen to HTTPS instead of HTTP in the outside world and use a particular certificate, or you can change the port and stuff like that. You can do this in the Docker Compose file. Otherwise, if you'd like to add additional resources, you would have to get the output from convert and then just do your own thing programmatically. But this is it. You can take the CF file from here and just, do your Python thing, JavaScript, whatever, and add anything there.
So it's not possible to actually embed the CloudFormation code in the Docker Compose file. I would inject it in the outputs.
Yes, you can just inject for Docker for target group and listener. This is the only thing that you can do. So right now it runs the update, as you can see here in the resources. It's updating the web service, and what it does supposedly is it, oops, wrong button. No worries. It instructs my AWS service to spawn, there you go, a total of 5 containers. Let's go here and see these tasks. As you can see, it activates containers. Also, I can see here metrics from my containers. Okay, so apparently CPU and memory utilization is really slow, so is really low. So let's go here, and as you can see, I'm refreshing here and I'm getting a different container every time. This is because I have the load balancer in front, and every time it serves me with a separate container because of, I think that's a round robin thing for all healthy containers. This is really amazing. I just did this with, here I have 7 and here I have 10, just 17 lines of code. Let me also here, I will also, resources, I would also like to instruct for CPU. Let me check the, I think I can add this here. Memory. I think this is the right one. I would like to double up the resources that that I give to my containers. So I think this would be 1G, would be 0.5. And I think it should be under the limits section. So what I'm going to do right now is I'm going to double up the CPU and memory of my containers. Again, property CPU is not allowed. Okay, I have to read this. So I was rushing here. So what I'm doing right now is I'm going to the documentation of the compose file. Reference, I'm going to deploy resources. CPUs. All right. So it was an innocent typo. Okay. Let's give it another go. Again, I think it would be useful if I did a split screen here to see. This is the configuration we're using. On the right, we have the baseline, which is general rules of how our application works, which is the image it uses, how it is being built, the ports that it exposes, and what command to run. This makes sense both locally and remotely. We could take build out and we could make it part of the override file to make it a bit cleaner. And on the left, we have Docker Compose .ecs.yml that says that I want 5 replicas. I want half a CPU and 1 GB of RAM for each one of these replicas. This is amazing also because I can use variables here and interpolate from the environment in the Docker Compose file. This is extreme. It makes it extremely easy for me to configure this in my CI system. Let's say it's GitHub Actions, Jenkins, or whatever. So I can just add here my app CPUs on ECS and default this to 0.5. So what happens here is I can also set this environment variable when running Docker Compose app, and it is just going to put it there for me. It's amazingly easy. This is something else that you don't get from Kubernetes out of the box as well, although they're doing some efforts towards this. Okay, they say that they updated here my CloudFormation stack. Let's go back. As you can see, the update is in progress. We can go to ECS. Here's my cluster. I have here my service. As we can see, the service has a new task definition. Every time that I update my service, the task definition gets updated as well. So now I am on version 3. On my next deploy, I'm going to move on to version 4 and so on. This is an automatically incremental part. Let's go here to the tasks that are running. As you can see, I have new tasks running, and this task here, if I open up here the task definition and move on, we can see that it has double memory and double CPU compared to a previous task. Let's go here and try to find the previous task before ECS kills it. So I have to say as well also that because this works on AWS with a load balancer and ECS and all this stuff, we get zero downtime deployments out of the box. So first, the load balancer will make sure that our new containers can serve our new traffic and then drop the old ones. So as you can see, this task here is based on an earlier task definition, which what the task definition does is it lets AWS know how to run our application. And because this is from a previous deployment, it has less memory and less CPU. So as we can see, the update happened successfully. And when the update completes, ECS will just kill my old containers and just keep the new ones, the big ones. So let's go back to the presentation. We saw how we can scale the size of our containers, and we saw also how we can scale the replicas of our containers. But what happens if we want to scale our applications not manually, but automatically? For example, I'm working on a project right now that gets spikes of traffics, and thankfully it runs on ECS. We're using the Docker Compose CLI, and we can instruct our application to auto-scale according to the resources that it occupies. And this is amazing. And here is how we can do auto-scaling on ECS via the Docker Compose CLI. So the Docker Compose CLI supports CPU-based container replica auto-scaling on ECS. What does that mean? It means that we can say to ECS, if my containers take more than, let's say, 60% of the CPU process that I have allocated to them, add one more. And this is amazing because, okay, we can do more sophisticated stuff, I'm pretty sure, but it's a great start. And it's amazing that we can just describe this with a single line and say that, okay, just increase my containers up to 10 when CPU is that big, and give them a minimum of this. So that's amazing. We can do this with the X AWS auto-scaling vendor attribute in our compose file. What does that mean is that if this attribute only makes sense on ECS and is not something generic. So what we've used up until right now, we could use it locally. We could use it on Azure, let's say, but the AWS auto-scaling attribute only makes sense for AWS. And if we try to use it in any other context in our Docker Compose file, this is going to crash. And this is why it's important to separate files and use this in a new one. So let's go here. I'm going to run into the documentation and say, okay, X AWS auto scaling Docker. I'm that lazy. I think this is it. So there we go. So we can use memory as well right now, but it's mutually exclusive. So what I'm going to do is I'm going to say here, I'm going to remove these resources and these replicas. We can use replicas and auto-scaling together. I'm just going to use auto-scaling. I want at least 2, a maximum of 4, and CPU, let's say 10%. We will just make it, let's make it 5. Just make it easy for it to scale. So what this is going to do is when our containers take up more than 10% of their available CPU, AWS will automatically scale our containers. And since we have a load balancer, everything is just going to work out of the box. So let me see if everything is updated successfully. Update is in progress. Come on. Okay, so this is one of the bad things that you get out of this is, but this has to do with Amazon, is that it can get really slow to get things updated, especially if you run things at scale. Update in progress. Oh, come on. Okay, so we have to wait for this to stop, because if it doesn't stop, the deployment will fail. Let me see if everything is running on the latest version. Yes. Yeah. Okay, great timing. So the update is complete. And right now we are going to do another update. So just to mention this, right now we had a really slow update because we had a whole bunch of containers 10 actually connected to our load balancer, and Amazon is really conservative of when to remove a running and healthy container from the load balancer. But since we can manipulate the CloudFormation templates, I'm pretty sure, because I was looking into it, because we ran into this issue with a project, we can make the load balancer more aggressive and remove containers faster. But we won't dive into this right now. But we can do this if we transform the CloudFormation file ourselves. So right now we did the update. Let's come here and see what happens. We have an update in progress. And what will happen is that it will update the web service and introduce some auto-scaling rules of how this is going to scale. Let's go here. Here is our cluster. Here is our service. And here we have a tab named auto-scaling. So when this will be ready, we will see the auto-scaling rules here updated. So let's not wait anymore about that. I think it's a good opportunity to have some questions. Right now, I think I'm running quickly through things, and this is partly because I'm really excited about this and I really want to use and showcase stuff to you. But also I want us to have plenty of time for questions and go back to any part and see how this works. So any questions?
We actually had already a question. The question was how you interact with the AWS resources, how the credentials are added. So in your case, I explained that you already had a profile created with your AWS credentials. Yeah. So you provided that to the ACS context. And once we create the ACS context, it knows where to go and find those credentials. Mm-hmm. And another question is if that would be possible if it's possible to achieve the same results using another cloud platform such as OpenStack. And I answered that probably it's not possible because, as we saw, everything ends up being CloudFormation. So since CloudFormation is AWS specific, there's no way to actually deploy using a, let's say, ECS context. They recently announced that ECS is going to be, you can deploy it anywhere you want. There is ECS anywhere. But even if you have the ECS service and the ECS API, you still need CloudFormation to create all the resources such as the load balancers, the log groups, and everything else. So unfortunately, it's just an AWS solution.
Yeah, that's right.
And we have a question which I think you had planned to answer. It's about the image being deployed on ECR. So would you like to show us the flow of having the local image deploying into ECR and how that would work in a
Yeah,
development workflow?
yeah, let's do this. So intentionally, I deployed my image publicly on Docker Hub to make things easy. But we can use ECR, the container registry of AWS, to deploy our applications there as well. And also, if we go here to the, not this, to the other documentation that I opened, just a second, Docker for ECS. Okay. We can, here, it has a section about private Docker images, and we can also add here credentials for any private registry that we want to use. We won't have to do this for ECR because ECR is integrated with ECS, and if we have our own private registry, we can just push and pull from there. So how would we do that? I would go to ECR here. And I will create a new image for my application. So I have the other one from a previous one. Let's name this. So I'm going to create a private image, and I'm going to name this AWS User Group /compose CLI. Okay. So this is it. I'm going to create the repository. Okay. Let's copy this URI and go back here, and I will open the override file because this is, no, not the override, the compose.yml file. And here, where I have this image, I will change it with this one. And what I'm going to do right now is I'm just going to run docker space compose space build. And okay, so this, why did this not run? Let me open the other terminal because this does not always work. Okay, guys, you know that these things happen in live demos, and I'm not afraid this is gonna work afterwards. Okay, okay. Docker compose. Yeah, because I know why this happened. Because I moved the build instruction into a different file. Okay, no worries. I'm being my own rubber duck here. So this is building the image. As you can see, I just ran, let me also zoom this a little bit. I just ran Docker Compose. I gave it both files. We need the first one that defines the name of our image, and the second file where we define how we're building this image. Here we can see that our image got the appropriate naming. And now I'm going to do the same thing, but I'm just going to run push. So this is going to push to ECR, but of course this did not work because I have not signed into the Elastic Container Registry. And I'm going to do this right now by using, okay, so this is, I'm going to use the SL profile, and I'm going to use, where is the name of the registry? Yeah, so you know, this is, you always have to run into this with ECR, but yeah, anyways. Okay, I authenticated to ECR, so now I should be able to push my image. Yeah, as you can see, I'm pushing the image to ECR, and after we see that auto-scaling works, let's go back here. Update is still in progress. No, this has not completed yet.
And while we wait for this completion, we have another question. How would you use other AWS services like RDS along with that? How would you pass the environment variables and stuff like that?
Okay, so first of all, you cannot create an RDS instance from Docker Compose. They have a discussion about that in the GitHub repository, but they have not. I think they're not doing this, and it doesn't make sense to me as well. But how would you do that? You can, when you create an RDS instance, you can also create a secret where you can store the RDS credentials. And here, as you can see in the documentation, you can also mount secrets from the secrets manager of AWS as files into your containers. And this is bonkers. This is amazing, because you can just get the secret information that you put there either automatically or via the UI, and just make them available as files into your containers. And because I had this conversation with a friend of mine a few minutes before this presentation, it intentionally does not publish this information as environment variables, because Docker tries to be security first, and environment variables can be leaked really, really easily. Not because there's something technical that makes it easy, but because software vendors that work for, do exception handling and debugging and tracing and stuff, they think it's a good idea sometimes to get to sniff the whole environment and push it on their own servers. So because this happens and software treats environment variables badly, Docker decides to put your secrets as memory mapped files in your containers. So what you would do is you would find your secrets in /run/secrets, and there you would find your AWS your RDS credentials, for example. This is amazing. You just put here the ID, the ARM of your secret in Amazon, and here you say what you want to use, and also you can use different keys. It just works.
So the only requirement in that case is that the credentials provided to the ECS context already have access to that secret.
Yes.
Right. Okay.
Yes.
So another approach I thought I didn't know about that. So my immediate first response was to use secrets, but I thought that okay, you would have to add some logic into your application to read those secrets on runtime, and in order to do that, you would need to have a role for the target container. Can you define the role that your tasks get?
Yes, actually, I think here you can, because I remember about that. I think you can define a role here, and also you can define policies as well. Great. So yeah, I'm using this in a project because we need to access some S3 files. So we just add the policy there, and the container has access to these files without using credentials or anything. And also below this part of the configuration, you can see how you can adjust the CloudFormation template inline, considering the target group and the listener as well. Here, for example, it indicates how you can set a certificate in your CloudFormation file. And so
if you can actually create roles and policies with code build with Docker Compose, because you say that you only define existing ones. Okay, you can attach.
Yeah, you can also create your own policy document to fine tune the IAM role, as it says here. But this is what you would mostly use. Just provide some policies. Let's see how this goes.
Another question we had is if you change your AWS resources, if you generate the CloudFormation template, you change the AWS resources, and then you deploy again, if they will be overwritten when you run Docker Compose up again.
No, it just overrides what needs to be overridden.
Are you sure about? I mean, if when you write. When you generate the template and you change it and deploy it, if you deploy it the second time, the template will be different, right? For example, if I deploy the template and add an S3 bucket, and then I run Docker Compose up, the S3 bucket won't be there. Will it delete the S3 bucket?
Okay.
Right.
So That's a good question. I think I'm pretty sure that it just runs stack create on the first time and stack update for subsequent times. So it would do what CloudFormation update would do, which is, I guess, deleting everything that's not there anymore.
Exactly. So my response to that would be, if you have any process of injecting your own resources or editing your own resources, you should deploy the stack with the same way every time.
Yeah,
And
of
not
course.
have, yeah.
Of course. So if you
that you have
post,
consistent results.
yeah, if you post process the stack, you should always post process the stack. Now this is really
We also
slow
have a
to.
hand raised, by the way, from
Okay.
Vasilis.
Oh yeah, sorry, I only saw the question. Vasilis, do you want to? You can unmute and ask the question.
Hello, everyone.
Hello.
Hi, Maris. Thanks for this beautiful demo. And
Thank you.
I'm happy to see that the demo gods are with you today.
Yeah. But also, I'm running this every day on multiple projects, so I was pretty confident that things would work. Okay, so it's quite slow right now to get the auto scaling stuff. So I'm going to kill this by hand. But sorry, you can move on.
Yeah, it's very interesting to see those concepts discussed today. We used to have a very similar tool in Blueground where we didn't use Docker Compose because I don't think this tool existed back then. But we used to have one of our homegrown tools that looked pretty much the same. And my question was that we also started using Fargate because it's very easy to scale and to spin up containers really fast. But soon we realized that Fargate is pretty expensive, so we had to move to the other backend of EC2.
Yeah.
And we found out that if we create our own servers, EC2 instances, and then run containers on top of them, it's much cheaper than using this black magic that is called Fargate.
Yeah, that's a valid point there, and I will say that I run workloads both on my own servers, where I run actually Docker Swarm, to be honest, and on Fargate. So I think that at the end of the day, everything comes down to the gross amount of money that you're spending on your application. So, for example, right now, if you're paying thousands of money more on Fargate compared to ECS, maybe it makes more sense to just pay a guy as a system administrator or DevOps engineer or whatever to handle these things, because it makes sense. And also, if you have a person there, you can that person can be creative. For example, you could just take the CloudFormation template and just change it to use the EC2 mode compared to the Fargate, let's say. So you can be creative there. So they used to have a mode that would allow running on EC2, but it looks that they don't want to support that. And right now, the only way to run on the EC2 backend with actual physical machines is if you want to use GPUs using this particular tool set. So for me, right now we're going to launch a few new applications that are not CPU intensive. So we're going to run just on 1 or 2 replicas on Fargate, which should be 9 or 20 euros per month, which is ridiculously cheap. If this would get too expensive, I think what I would do is I would just tweak. I would use the same tool set, but tweak the CloudFormation template to use EC2 as a backend. What do you think? How would you approach that?
Yeah, I think using just like you said, taking the CloudFormation template editing in place, maybe adding it to a Git repo, to track changes, and then deploying manually to CloudFormation sounds like a plan. And this also is in line with something like infrastructure as code principles and stuff. And yeah, definitely running on EC2 instead of Fargate allows you to, I think it's called bin packing, where you stuff as many containers as you can into a single instance, and you try to utilize the most out of the hardware that you pay. So yeah, that really sounds like a plan. I just wanted to know if Docker Compose supports the EC2 backend out of the box.
Okay, yeah. No, they don't. Intentionally, they don't. So I'm trying to find, do you know any tool that I can use to spam my service so I can see if the auto scaling takes on? I'm trying to see.
You can always replace the Flask command with a fork bomb or something.
No, I'm trying to find something really. Come on. Yeah, accept all cookies.
So another question we had is if there's a way to compare what's live with what's in the compose file. So before running Docker Compose up in the ECS context, if there's a way to preview the changes.
Yeah, you can. What I would do is I would add this to my CI, let's say to GitHub. I would convert the Docker Compose file to the CloudFormation template, and I would use diff with the existing template and see what it proposes. And that's a great idea, by the way. If you want to be really cautious about what you deploy. Anyway, I was trying to find a way to.
Additionally, you can, after creating the safe template, you can always create a new change set. There's a functionality in CloudFormation where you can say, okay, I want to create a change set for that template, the stack I've already deployed. And it lists every change, if it's a modified change, if it's a replacement change, and it will show you all the affected resources and how they're going to change.
Sounds good. So I'm running the stress test right now. Why? Okay. So I'm going
think
to.
You can just create a wave ping from terminal. You can create a wave ping from terminal.
And this is going to be enough?
Yes.
Okay.
You will actually DDoS your.
Just give the URL to Kostas and he will try and.
Okay. Yeah. Let me go here. Come on. Where is here? It should be. Okay, guys, you can find the URL here in the description. Just DDoS that thing, completely destroy it. So in the meantime, while you're destroying my application, I will also deploy my new version. What does it say?
He said that Kostas can just tweet it like he tweeted the meet link, and we had the Brazilian guys try to do this.
Yeah, that's right. All right. So so I will just Docker context AWS GR. So I am deploying this new version. Come on, just a sec. So I want to deploy this new version that has the ECR images there for this to be running and work. So I will move on with the presentation as you're destroying the service, and we want to see that auto scaling works. Costa, just let me know when after you spammed the service. So a few known issues. So Compose CLI likes the US East 1 region a bit too much. And what does that mean is that I have found a few cases that when it runs to GitHub Action, no matter where you want to schedule your containers, they are always going to find themselves in US Syst1. And this is ridiculous. It's really funny. And you cannot exec right now into your containers. You cannot run Docker Compose exec and get cell access into a container and debug stuff. But this changes because AWS implemented it, and now they have plans to implement it in the Compose CLI as well. So that's all, folks. A few useful links are there. I'm not going to run through them. You're going to get them in the presentation afterwards. I would like to ask your questions in the meantime while we see the auto-scaling working. Questions? No questions, but we can see here the CPU bumping up and the auto-scaling working. So we have a running count of 2. If this continues working, it's going to get even better.
Shouldn't we have more? What was the threshold for the scaling?
10% of the CPU. So it's just a Flask application that returns the host name. It's really hard to overload this thing. Yeah. But anyway, let's go back here. And yeah. Questions in the meantime?
You can either unmute your microphone and speak, or write them in the chat if there's any questions remaining. If not, it appears that we don't have any other questions. So thanks a lot, Paris.
Okay.
It was great. Sorry for the rough start.
Thank you. No worries. And me, sorry for extending time. So also I would like to say that if you're running into DevOps problems with your company, we are here to help. If you want to double down on Docker infrastructure as code, all this sweet DevOps stuff. If you want to build new projects with lean and automated processes, you can just send me an email at paris@withlogic.com. You can find this in the presentation afterwards. Thank you. The code will be available in a few minutes online on GitHub. Here is the link. I'm going to share the presentation as well. You can follow me on Twitter and send me questions, everything. I would love to talk with you. Thank you. Thank you very much for your time today.
Thank you, Paris, for the presentation. Sorry, everyone, for the rough start. We're going to send the slides and the presentation in follow-up. We will also have a new. We're always looking for new presentations. So if you have anything that you want to talk about or discuss, feel free to join our Slack community. We have a link both in the meetup, and I will send it in an email. And we're looking for any interesting new presentations. The next presentation is going to be in 1 month from now, and it's going to be about infrastructure as code and the AWS CDK. So if anyone is interested, you should join us. I think that's all. Thanks, Paris, a lot for your presentation. ECS, Docker for ECS is really amazing. Well. I have seen it work, and it's really magic.
Yeah, great.
Thank you very much.
Thank you, guys. Bye.
Have a good afternoon.